Hello and welcome to day 2 of AP Pre-Calculus. This is 1.2, Rates of Change. If you recall from the last lesson, rate of change is the same as slope. So if we have a positive slope, then we have a line that is going uphill. If we have a negative slope, we have a line that is going downhill. We will call that, in this class, the function increasing for a positive slope and a function decreasing for a negative slope. Remember, words have meanings. Here in AP Pre-Cal, we're going to talk about the rate of change at a single point on a function, whereas next year in calculus, you will talk about the instantaneous rate of change. We are not going to get quite to this part this year, but we are going to get you close, and then next year you're going to learn what's called a derivative, and that will give you the instantaneous rate of change. But for now, we're just going to worry about the rate of change at a single point, meaning the slope at a single point. Last but not least, I want you to understand that a rate of change at a given point can be one of three things: positive, negative, or zero. And we're going to need 2 points to do a rate of change because remember, rate of change is slope. The change in y over the change in x, or what we'll call delta y and delta x sometimes. It might be helpful to think about the rate of change as a roller coaster. I mean, who doesn't love roller coasters? So when you're in a roller coaster, like we have this guy over here, if he's going up to the top of the roller coaster, that is a positive slope. But right before he takes the plunge, he'll be right here at the top, and the slope is actually 0 at the top. And then all of a sudden he drops down, and anytime he's going down the roller coaster, that is a negative slope. Where our slopes go from positive to negative, we have to have a 0 slope. And that's a vocab word that we're going to have to learn, and we'll learn about those in a little bit. All right, we have example 1 here. We have a nice little polynomial function with labeled a, b, and c points, and we want to know what is the rate of change of f. What is the slope at these points? And remember, going uphill is a positive slope, downhill is a negative slope. If you're doing neither, it's a 0 slope. So here we are at A. To get to A, we start here on the left because we read left to right. We have to go uphill to get to A. So that is a positive slope, which means we would say A has a positive slope. And as we keep going, we get to the top. We don't care about the top yet. And we have to go downhill to get to B. B has a negative slope. Looks like Stoke, but that's okay. And then when we get to C, we're at the bottom. We're not going down or up. C has a 0 slope. Okay. And that's how you answer those. All right, example 2. Go ahead and pause the video and give yourself a chance to answer this question, and then we'll go over it. All right, so here we go. We're on our roller coaster, and we are at A. I'm going to draw a line that kind of touches A and kind of look at that slope. All right, so that looks like a positive slope. Let's move on to B. I'm going to draw another line. I'll make it a different color. All right, that's pretty close. I mean, it's as close as I can get it. That has a steeper slope. Let's move on to C, and I'm going to go ahead and draw the 2 slopes for C and D. All right, so there we have 4 different rates of change at 4 different points, and what we're looking for is the one that has the least amount. Remember, that least means the smallest value number. So obviously positive numbers are bigger than negative numbers, so the answer has to be C or D. Which one of those is the smaller value? And remember, as you get further in the negative, the bigger number has the smallest value. So D would be a smaller value, so that has the least rate of change. So the answer is D. All right, so average rate of change. By the way, in this class, we don't really want to do a lot of abbreviating, but we are allowed to abbreviate average rate of change as AROC. All right. Same with just regular rate of change. You can put ROC. But this formula right here, you see that there's an M. That should look familiar to you. Our old formula from Algebra 2 and before was y2 minus y1 over x2 minus x1. We could call that delta y. Delta means change in. It's a Greek letter, so change in y over change in x. But as you move forward in math, we change the way things look from a kind of an elementary view to, we try to make us feel better about ourselves being math people. So you'll see up here, instead of y, we have the function f, and our input is b. Remember, our input is our x value. So down here, our x value is b, and we put it in, that would be our y value. So this is really y2 minus y1 over x2 minus x1. It looks fancier, and that's how we will write it from here on out. So what is the difference between rate of change and average rate of change? Well, rate of change is really, we're trying to find the slope at a single point, whereas average rate of change, we're trying to figure out the slope over an interval of points. So you'll see here in example 3, if you look at our answers, they give us 4 different sets of intervals. So I'm going to go ahead and mark those intervals off, and then I'm going to draw some slope lines. So I'm going to pause the video. Okay, I tried to mark those points and make some slope lines as best as I could. And what we're looking for here is which of these slopes, which of these average rates of change over those intervals is the greatest. And remember, positive is greater than 0 and negative. And if you look at 3 of those, I have 2 negatives and a 0. The only positive slope is the green slope. So our answer is from 5 to 7. So C. Okay, here in example 4, we're talking about a function in the xy plane that will have a negative rate of change, which means a negative slope. To get a negative slope, our change in x and change in y have to be going in opposite directions, because if they're both going positive or if they're both going negative, we're going to have a positive slope. So we need to go through these problems down here and see which one is going opposite directions. So here on A, we have the age in years of a young child. So that is obviously getting older. That's going up. And the height of that child, we would assume that they are growing up. So those are both positive. So A is gone. The total number of points scored in a basketball game. So you're going to start with 0, hopefully, and then be scoring points throughout the game. And the time remaining in seconds, well, you start with all the time and you start losing the time as the game goes on. So B is looking pretty good right now, but let's go through C and D. Time in seconds, well, time goes up. The ball was thrown straight up in the air. What is the height? Well, that's going up and going down, so that's not going to be right, because we want to be negative throughout the whole thing. And then the radius in meters versus the area. As your radius gets bigger, your area gets bigger. If you want to go the opposite direction, if your radius is getting smaller, the area is getting smaller. Those are the same direction. So it does make sense that B is the answer. All right, example 5. You'll notice that it says calculator required, so go ahead and pause the video and put that function into your calculator. Okay, I went to Desmos and I put in the function, and this is the graph that I've got. So if you look at this graph, it's a parabola, it's a quadratic, and in a quadratic we have some positive slopes and some negative slopes. So we have to be careful of the words and what they're asking for. I noticed that A and B talk about positive rates, C and D talk about negative rates, and half of our graph will have positive rates, the other half will have negative. So I'm going to take a second and I'm going to put in the axis of symmetry. Remember that word from last year? So hold on just a second. All right, it might be a little bit hard to see, but that axis of symmetry is at around 2.5, right? So everything to the left of 2.5 on the x-axis has a positive slope, and everything to the right of that has a negative slope. So let's go ahead and look at our intervals here. From -10 to +8, well, that has both positive and negative slopes. So A is gone. So we want positive from negative 0.6 to 5. So let's see here. Negative 0.6, really close to the y. So we have some positive slopes. That's good. But as I get over here to across 2.5-ish, I got my negative slopes, so it can't be B. Let's see, K is negative from negative 10 to 2.4. So let's go ahead and look. Negative 10 is way over here, so I got some positive slopes, and it says it wants negative. So D, by default, better be the answer. Let's hope. Let's look. From 2.47, which is, if you actually use Desmos or your graphing calculator, you could have found the vertex, and it would have been 2.47. So from there to the right to 10, those are all negative slopes. So our answer did come out to be D. Okay, we're on our last question for the notes here. Notice it does say calculator required, and we really could use our calculator on this problem, but turns out we don't really need to. It's asking which of these has the greatest average rate of change, which one has the greatest slope. So we could do the slope formula for each of these intervals from 1800 to 1850, 1850 to 1900, so on and so forth. But if you notice, the jump is the same on each of these x values, the independent value. They jump the same amount. And that's kind of an important idea here in AP Pre-Calc. We're going to look a lot at things when they have the same difference between them, because when they do, we can kind of disregard those. And we can look which of these have the biggest jump. Because if the x jump stayed the same, then the y jump would give us the biggest slope. So really, it's just doing some subtraction here. And I'm going to be honest, you can just kind of estimate these problems. Like from 1800 to 1850, that's approximately a jump of 5. And then when we go from 1850 to 1900, that's approximately a jump of 8. Do I have to be more precise? I could be, but I don't really have to be, because this is a multiple choice question. And then when I jump from 1900 to 1950, we have a jump of somewhere around 16, maybe 17, right? Either one. And then last but not least, we have a jump of 11. So this right here has the biggest jump, which is 1900 to 1950. We could have wasted a lot of time doing the slope formula for each of those intervals, but that's kind of the quick, easy, dirty way to get it done on a multiple choice question.